All right, guys, here we go. We're going to look at the area of a triangle. And you say, but we have a parallelogram. Yes, okay, but a triangle is half of the parallelogram, okay? So its area is half of that. So here's our parallelogram, completely flexible. We can find its area because we know its base here is 1161, and we know that its height is 597 as it stands, okay? And their product is the area as shown over here. Now, okay, if I were to simply um, let me get that to a little bit more convenient value, okay, that we can easily see half of. All right, yeah, it's good enough. About 50. It doesn't really matter much. Okay, so here's something we can see easily take half of. All right, so now let's do something here. Let's make a triangle simply by drawing a diagonal, right? So let's draw the diagonal segment through C to B. Okay, and now that makes us a triangle. And let's make that into a triangle. Okay, from A to B to C, to A to finish it off. Okay, here's our triangle. All right, let's ask for what is the area of that. Okay, the area of that triangle is exactly half the area of the parallelogram. Okay, so it's half the height times base, which comes from the formula half of the parallelogram from which it comes. Okay, so now let's look at a um, a triangle in a more general sense. So let me open up my triangle here. Area of a triangle ABC. Okay, here we go. We're going to take a look at this, and now, so here we have any triangle, perfectly flexible. Okay, and we're showing all of what we formerly called the altitudes, okay, which are now the heights because the red dotted segments are the heights, all right? So basically, since we have three heights, we have three possible formulas, okay, as listed over here. So it's half the height times the base. Well, half of the triangle ABC, the area is equal to half of, if I'm using the base AB, then I'm using the height CH. Okay, so it's half of the height CH times the base AB, or half of the height AD times the base CB. Okay, or half of the height BH times the base CA. Okay, and any one of those formulas, or all of those formulas, should we say, will result in giving us the area of the triangle. Now, okay, let's look at something a little bit more conveniently, looking at the grid and uh, taking the triangle and moving it into more convenient locations. Okay, so let's just say that this was the arrangement of our triangle with the coordinates of A, B, C as indicated here, 0, -3, 6, 1, and 0, 5. Well, you can see in that arrangement, okay, given three possible formulas, the easiest to find is the segment CA, which is, of course, right alongside of the y-axis, okay, which we can see easily is going to be of length 8, okay, just by looking at the coordinates. And, okay, we can see that the segment BF is easily going to be computed as the height, okay? And so we can find those very easily just by subtracting coordinates, okay? Because B is right here, so its length, okay, is 6. And the length of AC is easily by looking at coordinates 8 and half of their product. Half of 6 times 8 is going to be 24. So another case in point, maybe more conveniently located, something like this. Okay, now we can see the easiest way to compute is to take the base along the segment AB, which is, okay, easy to compute its length because it's um, AB is easy to compute its length because its length is going to be simply 8 units. Okay, because it's right along the x-axis, as you can see, and hopefully you can see that right with the coordinates. And the height, CH, which is right along the y-axis, okay, which you can see is C is going to be 5 units up, so it is going to be, okay, at a height of 5. So again, so the easiest computation there is having the graph, finding that the height is perpendicular to the axis, just as in the previous case, allowing us to easily compute, okay? Even if we were to take something, let's say, like this, and here. Here you're going to see, of course, we have a right triangle. And in the right triangle, the heights are synonymous with the bases, or the heights are synonymous with the legs of the right triangle. So there, it's kind of easy to see how it's computed. And it's easy to see how you can compute that in each one of the ways. Okay, so now that we understand computing the area of a triangle, we will have you construct this figure in GeoGebra and get a better understanding of that for yourself. And we'll do that in the next lesson, in the next video.